cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to lower the temperature of the water. As this occurs, a small volume of water evaporated, lowering the temperature of the water being circulated through the water. Cooling towers originated in the 19th century through the development of steam engine, where condensers were used in the power generation systems. Condenser in the steam engine were used to condense the steam that are coming out of the turbines. In some areas with available large land, cooling ponds was used, but in big cities with limited land, the system took the form of cooling towers. Early towers were placed either on the rooftops or as freestanding structures. In 1901, an American engineer proposed a special design as a rectangular or circular shell, which was similar to a chimney stack, shortened vertically but laterally enlarged. At the top is a set of distributing troughs. Water from the condenser is pumped to top and then trickles down over wooden slats or woven wire screens, which fill the space within the tower. A hyperboloid cooling tower was patented by Dutch engineers Frederik van Ittersen and Gerard Kuiper in 1918 and were built in the same year near Heerlen.
Okay, so the cooling tower is operating according to the first law of thermodynamics, which is conversion energy, where energy can neither be created nor destroyed. So here is the basic principle of cooling tower. The energy that enters the system must exit as well as it can diffuse through the system. Energy that enters the cooling tower is in the form of hot water and was cooled from temperature 1 to temperature 2. So, the cooling applies convection of heat transfer, where air at temperature 1 was blown over the hot water and exited the cooling tower at some temperature 2. The main component of energy balance is enthalpy, which is H equal to delta U, represent internal energy, plus pressure multiplied by volume. Okay, so now we are moving on to the mechanism of the equipment. So, here how the cooling tower works. Warm water from a heat source, such as commercial air conditioning or industrial equipment, is sprayed at the top of the cooling tower. Okay, the warm water inerts the cooling tower and evenly disperses over the tower film. Then it flows down the film which spreads the water over a larger surface area. Why? You always wonder why. This is to increase the evaporation rate and for a faster removal of heat. Okay, so the larger fan in the cooling tower draw the air across the film, which accelerate the evaporation and further cools the water. The cool water then continues flow down the tower and back to the system and cool the heat source. As the system water evaporates, only pure water is lost. All the elements of the system water remain behind in less water volume. Then, to make up the water that lost from the evaporation, fresh water, normally this is industrial, fresh water introduced to the cooling tower through the mega apply. It carries extra element in the system water where they accumulate. This is because when there is more water evaporate, the more they need for makeup water to replenish the system. In order to reduce the concentration of the element of the system, a bleed valve then opens and drains the wastewater discharge.
So our group has choose the home refrigerator as an example of daily application that implement the same concept as the cooling tower. So this home refrigerator is built up of several tools and equipment. This is an example. This is the tools that build up the home refrigerator. Number one is the electric powered compressor. It is function to circulate the refrigerant throughout the system and also apply the pressure to increase temperature. Next is the capillary tube, which which serve as an expansion device and also to reduce the pressure of refrigerant inside the tube. Okay, next is the condenser. This tool is located at the back of the refrigerator and it is function to remove the heat energy and convert the refrigerant from gas phase to liquid phase. And next is the evaporator. This tool is located inside the refrigerator and it is function to absorb heat energy from the refrigerator space into the stream, and it will produce a low temperature area inside the refrigerator. Next, the important tools is the thermostat, which function to monitoring the temperature inside the refrigerator and automatically will switch on or switch off the compressor. Next is the fluid material that flow in the refrigeration circulation system. This is the type of refrigerant that available in our market today. At the 20th centuries, the fluorocarbon, especially the CFC, is widely used as a refrigerant. However, they have been replaced by a more environment-friendly refrigerant, which is the refrigerant 134A. It has a good dielectric properties as it has high thermal stability, low boiling point, chemical inertness, non-toxic and non-flammable. So that is the tools and material that build up the home refrigerator. Thank you.
In this slide, I will explain the flow chart of the refrigerator. So for the first component is the compressor. It takes in the refrigerant 134A vapor to keep the flowing through the system at specific rate flow and pressure. The rate flow will depend on the size of the unit and pressure will depend on the type of refrigerant used and also desired evaporator temperature. The next one is condenser. As you can see, the red dots is the discharge vapor while the red solid represents the high pressure of liquid refrigerant. Condenser used to condense the refrigerant vapor into liquid phase. When the hot refrigerant vapor discharged from the compressor travels through the condenser, the cool water flowing through the condenser coil and absorb enough heat from the vapor to cause it to condense. Heat is removed to the surrounding or out from the refrigerator. The next one is the metering device. This is the expansion device. It is used to divide the point between the high pressure and low pressure sides of the system. It is also designed to maintain the specific rate flow into the low side of the system. This is to avoid any incorrect quantity of refrigerant flow into the evaporator. And last but not least, in evaporator, there will be relatively warm air or water inflowing over the evaporator coil. The system is designed to move the warm air or water into the cool evaporating refrigerant. This will continue to cool the air inside the refrigerator, and then heat will move into the evaporated refrigerant to be released out from the refrigerator later in condenser.
The application of cooling tower in the power plant industry. As we all know, the power plant will produce waste heat energy as its byproduct, and this byproduct will produce rise in temperature in the atmosphere. So the natural draft wet cooling tower at many power plants such as nuclear power plants and large fossil fuel fired power plants will use hyperbolic chimney-like structure to release this waste heat energy to the ambient atmosphere by evaporation of water. Next, the application of cooling tower in the petroleum refineries. In this industry, the mechanical induced draft or forced draft cooling tower is used, where the fans will provide a movement upward through the downcoming water. Lastly, in areas with restricted water use, the dry application of cooling tower is used, particularly for small industrial, and the dry cooling system used is air instead of water to cool down the stream. In conclusion, the cooling tower is an essential component for every building, and a routine operational maintenance is very important to keep the efficiency of this cooling tower. Thank you.